Hello students, how are you all? Hope all of you are doing very well. I am back with another chapter called Work, Energy, Power. So today we are going to solve numericals based on this chapter, that is Work, Energy and Power. Okay, so you all of you know that I have been solving previous Neet questions. Once after completion of this, I am very eager to upload one shot videos also, so that it will help you to clear Neet examination. Let's get started. The very first question is given based on introduction of this chapter. Let's get started with that. So question number 1. Okay. A particle moves so that its position vector is given by r bar is equal to cos omega t x cap plus sin omega t y cap. Okay, let me write down the given data. So they give a position vector r bar is equal to cos omega t x cap plus sin omega t y cap. Okay, what is the phase difference between cos omega t and sin omega t? It is 90 degrees, right? Okay, and they gave these directions very clearly. One is along x axis, another one is along y axis. Okay, next, what is the question they're asking? Where omega is a constant. Okay, which of the following is true? We have to check out the option. First one is velocity is perpendicular to r bar and acceleration is directed towards the origin. That means from this position vector, I have to find out both velocity and acceleration. In this question, position vector is given with respect to time. To find out velocity, you just have to divide position vector with respect to time. That is dr, differentiate position vector with respect to time. What's the differentiation of cos omega t? It is minus omega sin omega t, because we are differentiating with respect to t, not with respect to omega t. If you are differentiating with respect to omega t, then answer is going to be only sin omega t. As you are differentiating with respect to t alone, you are going to get one more constant, that is omega. Okay, minus omega sin omega t x cap plus sin omega t differentiation is omega cos omega t y cap. This is the velocity. Okay, so just common omega from this, then keep it as it is. So let's talk about acceleration first. Acceleration is equal to dv by dt. I just have to differentiate velocity with respect to time, then I'll get acceleration. That is going to be minus omega into sin omega t differentiation, omega cos omega t x cap. Okay, so plus omega cos omega t differentiation minus omega sin omega t y cap. So from this you can common minus omega square, then I can replace it with cos omega t x cap plus sin omega t y cap. Is it looking like a position vector? Yes, it is. Let me draw whatever the information we have right now in terms of vector notation. Okay, let me consider coordinate axis. To make it easy, I am going to assume cos omega t as let me consider it with a variable a and sin omega t with b. Okay, that means I can write down it is as a x cap plus b y cap. What about this? Minus omega sin omega t is replaced with a b, right? Minus omega into b x cap plus omega into a y cap. Then what about this? So this is finally can be replaced as minus omega square a x cap minus omega square b y cap. Okay, so same thing I'm going to represent it in the form of a vector. Okay, so let's observe this carefully. So first one, position vector, A x cap, B y cap. So this is how it is going to be. Both are positives, right? So this is how I can represent it. This is A and this is B. So as phase difference between them is 90 degrees, magnitude of sin omega t and cos omega t is, so this resultant I can draw like this. Okay, so this is R bar. Let me draw V bar also. V bar is minus omega B x cap. That means it is going to be negative x axis. Okay, so this is going to be minus omega B. And what about remaining omega into A? So which is along x axis, sorry, y axis. Let me represent that. So this is, it is in the same direction. Then resultant is going to be now in this direction. Okay. Now what is the angle between these two? So angle between these two is going to be 90 degrees. So this is how we can decide. Okay. What about acceleration? Acceleration is drawn as minus omega square A minus x cap and minus y cap. So both we have, this is how it is. And the direction of acceleration is like this. This is how acceleration is directed. Super. Check out the which option matches here. Velocity is perpendicular to r bar and acceleration is directed towards the origin. Super. First option itself is correct. Let's move on to the next question. So next question they are asking. So let me read it out. If a vector a bar is equal to cos omega t I cap and sin omega t j cap plus sin omega t j cap and b bar is also given, these are functions of time, then the value of t at which they are orthogonal with each other. They said they are orthogonal with each other in the sense they are perpendicular with each other, right? If two vectors are perpendicular with each other, then dot product of those two vectors is generally 0, right? Let me use that point. So dot product of these two vectors is 0, that is, so a bar dot b bar is going to be equal to 0 because they are orthogonal vector. Orthogonal in the sense perpendicular vectors. A bar is cos omega t I cap plus sin omega t j cap dot cos omega t by 2 I cap plus sin omega t by 2 j cap. Dot product of these two vectors is 0. So cos omega t into cos omega t by 2 is cos square omega t, sorry, can be replaced as cos omega t into cos omega t by 2. Next plus sin omega t into sin omega t by 2, which is equal to 0. If you observe this one looks like a cos of a minus b formula. Cos of a minus b is equal to cos a cos b plus sin a sin b. Then I can convert this is in the form of cos of omega t plus omega t by 2, which is equal to 0. Then at what value of theta I am going to get a cos function as 0 at theta is equal to pi by 2. Let me substitute that. Omega t plus omega t by 2 can be replaced as pi by 2. Omega t plus omega t by 2 is going to be 3 omega t by 2. Sorry, we made a mistake here. We have, it is cos of a minus b formula, right? Okay, so this is a minus b. It's going to be a minus b. So omega t minus omega t by 2 is going to be omega t by 2, which is equal to pi by 2. 2 will get cancelled, then omega t is equal to pi, then t is equal to pi by omega. So check out which option is matching. Option A. Okay, let's move on to the next question. Next one is also of the same model. They gave two vectors and they said if a vector is 2 I cap plus 3 j cap plus 8 k cap is perpendicular to the vector 4j cap minus 4I cap plus a k cap. Then the value of a they're asking. Okay. Third one. Given two vectors, I've named them as a bar and b bar. If you observe second vector b bar, first they have given j cap instead of I cap. So while you are writing it down, so check out that direction carefully. So here I changed this, that is minus 4 I cap plus 4 j cap plus a k cap. I need dot product. So because they said that these two are perpendicular vectors, right? Then dot product of those two vectors is 0. So what is the meaning of dot vector? Multiply respective I cap, j cap and k cap coefficients and then add them. Multiply respective coefficients, then what you are going to get? 2 4s are minus 8, 2 into minus 4, minus 8 plus 3 4s are 12, then 8a which is equal to 0. Then 8a is equal to minus 8 plus 12 is plus 4. If you send it right side, it will become minus 4. Then a is equal to minus 1 by 2. Which option matches? Option B. One more question. Next question is also of the same model based on dot product. So they said the vector sum of two forces is perpendicular to their vector differences. Okay. Vector sum is perpendicular to vector difference. In that case, the forces, okay, super. So vector sum of forces, let me name that is as F1 bar plus F2 bar. This is vector sum of forces, which is perpendicular to vector difference, that is F1 bar minus F2 bar is equal to 0. Same concept. If two vectors perpendicular with each other, dot product of those two vectors is going to be 0. Okay, how the dot product is going to be 0 in the sense, so dot product of two vectors is a bar dot b bar, which is equal to ab cos theta. If theta is 90 degrees, that means theta here it is angle between a bar and b bar. If it is 90 degrees, then ab cos 90 value is 0. So complete dot product of two mutually perpendicular vectors is going to be 0. That is how dot product of two vectors is going to be 0. They gave in the question very clearly that sum of two forces is perpendicular to their difference, their vector difference. Okay, let me multiply both of them. If you multiply both of them, then you are going to get dot product f1 square, then minus f1 f2, no, just dot, remember it is f1 dot f2, next f2 plus f2 dot f1 minus f2 square, which is equal to 0, right? So this one will get cancelled out. Then f1 square is equal to f2 square, right? That means f1 is equal to f2. So it means those two forces are equal to each other. Which option? Option A matches. Hold on. First of all, let me really read out that option. So they are equal to each other. Next one is equal to each other in magnitude. This is important. I wrote here magnitude of those two vectors. In magnitude wise, they are equal. Okay, well, we have to check out. Equal to each other, we can write down it is as f1 bar is equal to f2 bar also. That is completely wrong. So magnitude wise, they are equal. Let's solve another question. So if you observe question number 5, it is exactly similar to question number 1. You can go through that solution once again. Now which option is correct? Velocity of the particle is perpendicular to the position vector, right? So for the fifth one, option D is correct. If you want, you can go through this solution once again. First question solution. Fifth one and first one both are same. Next, question number 6. Fifth one completed, right? So let's say question number 6th solution. So they gave two vectors, which is a bar is equal to 3i cap plus 4j cap plus 5k cap, and b bar is equal to 3 I cap plus 4 j cap minus 5 k cap. And they are asking angle between the two vectors. How to find out angle between two vectors? By giving vectors itself. We know dot product of two vectors, that is a bar dot b bar is equal to ab cos theta, right? What is theta here? Theta is angle between a bar and b bar. This is what they are asking. From this, what is going to be cos theta? Cos theta is equal to a bar dot b bar by ab. So this a and b simply represents their magnitudes. Okay, so let's use this formula. Cos theta is equal to, first of all, find out dot product of this. What is the dot product? Multiply respective I cap, j cap and k cap coefficients. 3 3 is a 9 plus 16 minus 25 divided by magnitude of this. Magnitude of the first vector is going to be, so a bar magnitude is equal to root of 3 square plus 4 square plus 5 square. It's going to be 3 square plus 4 square is going to be 25 plus 25. It is going to be 2 times of 25. We can write down it is as 5 root 2. Check out once again. I'll repeat this. So 3 square is 9, 4 square is 16, which is 25, plus 5 square 25. It is going to be 50. It can be replaced as root of 25 into 2. So I can write down this as 5 root 2. Got it? So similar to a bar, b bar also you are going to get the same magnitude, root of 3 square plus 4 square plus minus 5 square. So it can be replaced as like this. So root of 3 square plus 4 square plus minus 5 whole square. So this will give you the same answer, that is 5 root 2. Let me substitute them. It is 5 root 2 into 5 root 2. And it will give you, so 9 plus 16 is going to be 25. 25 minus 25 is going to be 0. So 0 by anything is equal to 0 only. This is anything, whatever it may be the value. So if you need exact value, so 5 5s are 25. Root 2 into root 2 is 2. 25 into 2, 50. So answer is going to be 0. So at what value of theta we are going to get a 0? So theta must be 90. At what value of theta cos theta will be 0? At theta is equal to 90 degrees. Okay. Which option matches here for question number 6? Option A. Very good. Okay, let's move on to the next question, 7th question. So which is based on notions of work and kinetic energy and work energy theorem. What is work energy theorem? Work energy theorem states that work done by all the forces is equal to change in kinetic energy, which is equal to final kinetic energy minus initial kinetic energy. This is work energy theorem. Okay, let's try this question. Consider a drop of rainwater having mass 1 gram falling from a height of 1 kilometer. It hits the ground with a speed of 50 meter per second. Okay. So a drop of mass 1 gram. 1 gram in terms of kg, 1 into 10 power minus 3 kg. This is the way to convert grams into kg. Falling from a height of, it is falling from a height of 1 kilometer. 1 kilometer is replaced here with 1000 meter. Okay. So when it hits the ground, with how much velocity it is hitting the ground? It is hitting the ground with a velocity of 50 meter per second. Okay. What is the question they are asking? G is constant and its value is 10 meter per second square. Okay. So we have to find out work done by gravitational force and the resistive force of the air. Okay, so how to find out work done by gravitational force? Simple formula, mgh. Work done by gravitational force is nothing but potential energy of that drop at a height 1000 meter, which is equal to m value is 10 power minus 3 kg and g value is 10. Height of the particle, height at which the particle is dropped is 1000 meters. So this 1000 and 10 power minus 3 will get cancelled out. Then work done by gravitational force is going to be 10 joules. So whether it is positive or negative, we can decide. Object is force acting towards down, and displacement of the particle is also in the same direction. Definitely work done by the gravity is going to be positive. Check out the option which is having case 1 as 10 joules. That's going to be the answer. Look at the option. Option C is correct. Okay. Then how can I calculate resistive force? I said work energy theorem is work done by all the forces is equal to change in kinetic energy, right? Let me consider that. So work done by all the forces in the sense work done by gravitational force and work done by resistive force is equal to change in kinetic energy. That is final kinetic energy minus initial kinetic energy. Initially we are dropping the particle. What is the meaning of dropping? What about its initial velocity? Initial velocity is equal to 0. That means initial kinetic energy is 0. And final kinetic energy of this particle is going to be 1 by 2 mv square. Do we know work done by the gravitational force? Yes, we know. That is 10 joules. WR, that is work done by resistive force. Then work done by resistive force is equal to 1 by 2 into 10 power minus 3 kg into V value. What is the velocity with which it is hitting? With 50. 50 square is going to be 2500 minus 10. So let us see what's the answer we are going to get here. So here 10 power minus 3 into 10 power 2 is going to be 10 power minus 1, which is 2.5. Sorry. Yes, correct. It is 2.5. 2.5 divided by 2 is going to be 1.25. 1.25 minus 10. Then answer is minus 8.75 joule. This is work done by resistive force. Yes, it is correct. Let's move on to the next question. Now question number 8. Let me read it out. A particle of mass 10 grams moves along a circle of radius 6.4 centimeter with a constant tangential acceleration. Okay. So whenever you come across the question, first of all try to write down the diagram. Mass of this particle is 10 grams. Convert it into kg, that is 10 into 10 power minus 3 kg. Okay. What is the radius of this circle? A radius is 6.4 centimeter. That radius you can convert in terms of meter, that is 6.4 centimeter. Convert into meter is 10 power minus 2 meter. Okay. So with a constant tangential acceleration. Tangential acceleration is constant. Okay. That means will velocity of the particle in circle, speed of the particle in circle changes or remains the same? It will changes because of tangential acceleration. If tangential acceleration is 0, there won't be any kind of change in speed of the particle in circular path. Okay. What's the question they're asking? What is the magnitude of this acceleration if the kinetic energy of particle becomes equal to 8 into 10 power minus 4 joules by the end of second revolution after the beginning of the motion? Super, very good. Question they are asking, I have to find out tangential acceleration at the end of second revolution. At the end of second revolution. From beginning, right? So what is the meaning of from beginning? Is it having any initial velocity? No. Initial velocity is equal to the 0. That means initial angular velocity is also 0. So we know from circular motion the relation between linear variables and angular variables, and also we know that equations of motion in rotating variables. Okay, so let's use those equations of motion in rotatory motion. That is theta, instead of theta, let's find out omega final square. Omega final square is equal to omega initial square plus 2 alpha theta. Do you remember this equation is looks like v square is equal to u square plus 2as, no? Same thing we are going to convert into rotational terminology. Okay, let's use this equation and try to find out. So the meaning of at the end of second revolution, in the sense particle traveled 2 revolutions. So meaning of 2 revolutions, one complete revolution is equal to 2 pi radians. Then 2 revolution, in the sense 2 times of 2 pi radians. So this is actually theta, angular displacement, which is 4 pi radians. Okay, so they gave angular displacement. Okay, so what about initial angular velocity? We know that initial angular velocity is 0 because it is starting from the rest. From the beginning they said, that means it is at rest initially. So omega initial is 0. Then omega final square is equal to 2 alpha theta. So this is what I have. Relation between tangential acceleration and alpha is at is equal to r alpha. Okay, so you can replace alpha with at divided by r. Let me substitute it here. Omega final square is equal to 2 into at tangential acceleration divided by radius into theta. I'm just converting into whatever the data that I know. So do I know omega final after 2 revolutions? I don't know. Angular velocity after 2 revolutions? I don't know. Then what should I have to do? I just have to convert this angular velocity into linear velocity. How to convert angular velocity into linear velocity? V is equal to r omega relation. Then omega is equal to V by r. So that r here we are replacing it is with a smaller, right? See, this is the relation between linear velocity and angular velocity. Let me substitute it here. It is going to be v square by r square is equal to 2 at by r into theta. So r will get cancelled. Then 1 by 2 v square is equal to at into theta into r. Do I know final velocity? No, I don't know. They gave its kinetic energy. Formula for kinetic energy. Kinetic energy is equal to m v square by 2. 1 by 2 m v square, no? Now I have only v square by 2. Then from v square by 2, can I write down it is as kinetic energy by m? Yes, I can. Okay, so now I am converting everything into a given data, which is going to be kinetic energy by m, which is equal to at into theta into r. Do I know kinetic energy? Yes, they have given data. Do I know mass? Yes, I know mass. And do I know radius? Yes. And do I know theta? Yes, I know. How many revolutions? Second revolution. This is theta. Let me substitute all those things. It's going to be 8 into 10 power minus 4 divided by mass is 10 into 10 power minus 3, which is equal to 80 into theta is 4 pi into r value is 6.4 into 10 power minus 2. If we substitute all these things, we are going to get answer approximately as 0.1 meter per second square. Try these calculations. See, I just converted this one into known variables. That is the reason it will take more time to understand this. For explanation only, I am taking this much of time. Try to understand. If I know the formula, then I can substitute it directly. So there is another method to solve this kind of question. So that is going to be work done. So we have two types of forces are acting here. Let me show you that. Okay, so let's move on to the next question. That is, A bullet of mass 10 grams leaves a refill at an initial velocity of 1000 meter per second and strikes the earth at the same level with a velocity 500 meter per second. The work done in joule for overcoming the resistance of air will be okay. Super. Simply, we can use work energy theorem. Work energy theorem. So they gave initial velocity and final velocity, and they're asking work done. So what is work energy theorem? Work done by all the forces is equal to change in kinetic energy, right? Which is equal to final kinetic energy minus initial kinetic energy, which can be replaced as 1 by 2 into m is constant, v final square minus v initial square. Okay, so 1 by 2 into what's the mass of this particle? 10 grams, which is going to be 10 into 10 power minus 3. Okay, so it's a mass of the bullet into V final is 500 square into 500 square minus 1000 square. In this calculation, do one thing while you are calculating, you may feel it is as difficult. Do one thing which is common. Can I write down it is as 5 into 100 whole square? That means 100 square can be removed outwards, so it is can be replaced as a 10 power minus 2 into 100 square. 100 square in the sense 10 power 4 you can common into 5 square 25 minus this one remaining is going to be 100. Okay, super. Which can be replaced as 25 minus 100 is 75, right? Okay, so 75 into minus 75, I need only magnitude whatever the work done here, so it can be replaced as 10 power plus 4 into 10 power minus 2 is 10 power 2. It's going to be 7500 divided by 2, which is equal to 3750. I'm just calculating only magnitude, that's why I didn't consider negative here. And which option matches? Which option? B is the correct answer. Okay, let's move on to the next question. Question number 10, which is based on work done. So 10th one solution. A particle moves from a point minus 2i cap plus 5j cap. They given initial position, that is r1 bar is equal to minus 2i cap plus 5j cap. From this position to another position particle is moving, that is r2 bar is equal to 4j cap plus 3k cap. Okay, now when a force of 4i cap plus 3j cap is applied and they are applying a force of 4i cap plus 3j cap is applied, they are asking how much work done here. Okay, general formula for work done. Work done is equal to F bar dot P bar. This formula is applicable if force is constant. If force is variable, we are going to use F bar dot dr bar. So this formula is applicable if force is variable. So these are the two formulas we are going to use in work done calculation. Check out the given force is constant or variable. How can I decide given force is a constant or variable? If it depends on any other variables, then that is going to be a variable force. If it is not depending upon any other variable, then it is a constant force. So here we have a force, constant force. So then which formula I have to use? This is the formula. So let me use that, and W is equal to F bar dot D bar. D bar is the displacements, final position minus initial position. So let me substitute those values directly. F bar is 4i cap plus 3j cap dot R2 minus R2 bar minus R1 bar, that is 4 minus of minus 2, 6i cap, 3 minus 5j minus 2 j cap. So and dot product of these two, 4 6 24 minus 6. Answer is 18 joules. Which option? No, option itself. That means we made some mistake here. Here it is. R2 bar given as 4j cap plus 3k cap. I am subtracting this directly. How fool I am. Okay, it's a mistake. So let me substitute this R2 bar minus R1 bar. So R2 bar is given as, I can write down it is as 0 I cap plus 4 j cap plus 3 k cap. Even this small mistake also costs us anything. Okay, so minus of minus plus 2 I cap minus 5 j cap. So there is no k caps, minus 0 k cap. Why minus? Because I'm subtracting this. So it's going to be 4 I cap plus 3 j cap dot 2 I cap plus, minus of 4 j cap minus 5 j cap minus j cap plus 3 k cap, and dot product of these two, I cap and j cap are multiplied. It's going to be 6 minus 3, 8 minus 3, which is equal to 5 joules. This is the answer. So which option matches? Option C. Check out carefully. Here we have made a mistake. Okay, well, let's move on to the next question. Question number 11 is also of similar model. So let's try that. A uniform force of 3 I cap plus j cap newtons acts on a particle. F bar is uniform in the sense constant or variable. It is a constant. 3 I cap plus j cap acts on a mass of the particle. M is equal to 2 kg. Hence a particle is displaced from position 1 to 2. That is R1 bar is equal to 2 I cap plus, they didn't give j cap. Let me write down it is as 0 k cap so that we can avoid confusion, plus k cap, and R2 bar is equal to 4 I cap plus 3 j cap minus k cap, and displacement vector is equal to R2 bar minus R1 bar, which is equal to 4 minus 2, 2 I cap, 3 minus 0 plus 3 j cap, minus of minus plus, it is minus k cap, it is minus 2 k cap. So this is displacement vector. A question they're asking work done is equal to F bar dot D bar. So which is equal to, just observe dot product of these two, multiply respective I cap and j cap, k cap coefficients. It's going to be 3 2s are 6 plus 3. Answer is equal to 9 joules. Which option matches? Option C. That's all. Next, question number 12. So what's the question they're asking? A body moves a distance of 10 meter along a straight line under the action of 5 newtons of force. A body moves how many meters? 10 meters under the action of 5 newtons of force. 5 newtons of force. Object is moving 5 meter. Okay. If the work done is 25 joules, then angle between the force and the direction of motion of the body. Okay. They given force and displacement. They didn't mention at what angle they are applying this force. So that's what we have to find out. So just name this as F is equal to 5 Newton. Okay. So what's the work done formula? Work done is equal to FD cos theta, right? So what is the work done value they have given? It is 25 joules. Force 5 newtons. Displacement 5 meter into cos theta. So 5 5s are 25, 25 will get cancelled. Then cos theta is equal to 1. At what value of theta you are going to get cos theta as 1? 0 degrees. Which option matches? Nothing. Sorry. Displacement they have given it is as 10 meter, no? Substitution mistake. Okay. So it is 10 meter. So this is 10, and it is going to be 25 to the cos theta is equal to 1 by 2. Now what value of theta we are going to get cos theta as 1 by 2? It is 60 degrees. So which option? Option A is correct. Super. Observe the next question, question number 13. It's a very simple question. So they gave a force and object is displaced by 10 j cap and they're asking work done. Okay, so F bar is equal to minus 2 I cap plus 15 j cap plus 6 k cap, and displacement is equal to 10 j cap. This 10 j cap I am going to replace it like this: 0 I cap plus 10 j cap plus 0 k cap. I need work done. Work done formula is F bar dot D bar dot product of two vectors. Multiply respective coefficients, you are going to get 150 joules. Which option? Option A. Very good. Okay, next question number 14. Okay, so when a body moves with a constant speed along a circle, when a body moves with a constant speed along a circle, in the sense, what kind of motion is that? Speed is constant. It is a uniform circular motion. In uniform circular motion, tangential acceleration is equal to 0, right? Then which acceleration is present? Centripetal acceleration. This centripetal acceleration is equal to perpendicular to the motion of the particle, right? This is force and this is a displacement direction at any point. Force and displacement are perpendicular with each other. Then work done is equal to 0. That's which option? Option A. No work done on it. No acceleration produced. Tangential acceleration is 0, but centripetal acceleration is always present. Then only particle can move in a circular path. They said velocity remains constant. See, speed constant, it doesn't mean velocity to be constant. That means when particle reaches here, speed remains constant, but direction changes. Now, if direction is changes, velocity is also changing. Speed alone is constant. Velocity changes. And more thing, no force acts on it. Definitely force acts on it, which is a centripetal force, and it is directed towards the center. So only option 1 matches. Very good. For question number 14, which option matches? Option A. Good. If you are confusing how velocity changes, why speed is constant, let me prove it. So I said speed, they said it is speed is constant, right? Speed is constant. There is no tangential acceleration. Tangential acceleration is the responsible acceleration which changes the speed of the particle in a circular path. Now in this case, particle is moving upward, first starting point. Imagine like this. It is moving with a speed v. When it reaches this point, it moves towards left with the same speed. At this point, it is going to be downward motion. At this point, it is towards right. If you observe position 1, 2, 3, 4, magnitude of velocity, that is v, is constant. Speed of the particle is constant, but if you observe here it is moving along plus j cap, and this is minus I cap. Here it is of minus j cap direction, and it is of plus I cap direction. So direction of this particle is changing, right, with respect to time. Definitely velocity changes, but magnitude of velocity remains constant. That's why its velocity changes, but speed remains constant. That's the meaning of that. Here velocity changes, so at different position it is having different direction. That's why velocity changes, because velocity is a scalar quantity or a vector quantity, because it is a vector quantity, whereas speed is constant because it is a scalar quantity. And one more thing, kinetic energy also remains constant, because kinetic energy depends on speed or velocity. It depends on speed. 1 by 2 mv square. In place of v, we are going to substitute a speed. Okay, that's why kinetic energy of the particle is also remains same. Whenever this particle is moving with a constant speed in a circular path, centripetal force is towards the center. then only particle can move in a circular path. So work done by the centripetal force is equal to 0 because centripetal force is perpendicular to displacement of the particle. So this is the basic theory behind this question. Hope you understood.